Right, so today we are going to learn some basic properties in algebra. So these are related to how we calculate numbers. So this is, the basic properties for addition or subtraction and multiplication. So the first property, the first rule is called commutative. So what it means by commutative is when you have two numbers.
If you have 12 times 4, you switch it around 4 times 12.
Yes. Now let's look at first for the addition or subtraction, yeah? Yeah, basically when you have two numbers like, for example, 12 plus 4, this is equal to 4 plus 12. Okay. Now, when you have, for example, two numbers, yeah, let's say A, you add with the second one B, so that's also equal to B plus A. Okay. Now what about for multiplication? So you have mentioned the example before, 12 times 4, which is 48. So it equals to 4 times 12. Yeah, so you can swap basically, when you have A times B, that gives you B times A. So this is the commutative property, yeah, for addition. And then for multiplication. But what about if you have subtraction? So for example, when you have 12 minus 4
equals to 4 minus 12.
No.
But the answer is 8.
12 minus 4 is 8, yeah. But you can't swap them because when
it will be a negative number.
Yeah, so it will give you a negative number.
Okay.
So what do you think with the subtraction?
You can't use commutative law.
Well, actually, we still can use the commutative, but in this case, you need to know what do we need to do with this one, yeah? So look at this. This is very important. When you have this subtraction here, actually what happens is it's like you have, addition with a negative number. So this is very important, yeah, when you have, for example, 12 minus 4 is like you have 12 and then you add with negative 4. Yeah. So there are some negative numbers actually that you need to realize, instead of just positive numbers, yeah. Now with this one, when you look at now, we have, remember, A plus B, and according to the commutative law, it becomes B plus A, yeah? So in this case, what is B here?
B is 4
No. So if you look at the similarity here, this is your plus and plus, right? So in this case, A equal to 12, yes?
B equals to negative
Yes.
4.
Yes, that can happen. So in this case, B is negative 4. Yeah. So you see, when you have 12 minus 4, it is actually equal to negative 4 plus 12.
Okay.
So normally when you have a negative number, yeah, sometimes it's better to put the bracket like this one, especially when that negative sign comes after another sign. So look at this one. So you have a positive and then you have a negative. So it's better to put the bracket.
Okay.
Yeah. So when you have subtraction like this, 12 minus 4, this is actually just like addition, simple addition. But then what happens is you add with negative number. Okay. Yeah.
And negative numbers are less than 0.
Negative number is less than 0.
So that means if you plus 12 plus negative 4, 12.4.
No, no. So what happened is like this. If you try to draw them, so this is called real numbers, yeah, which include the positives, yeah, and then 0, okay, and then the negatives. And I think you already learned some of them, yeah. So they are actually fractions. And the last thing is, no, the decimal is just like fraction actually. Yeah, decimal and fraction, they are the same thing. And the last one is called the irrational. But let's not worry this last number, irrational. Yeah, we will learn about this later, okay? Now I think let's look at the first 3 of real numbers here, you know, the positive, 0, and then the negative. Yeah. So when you have, you know, the positive and then the negative and 0, you can plot them in the something so called the number line. So this is number line. Have you ever heard about number line?
My friend Oscar uses it all the time. My friends call him the king of number lines.
Okay, so what happens is you can put those numbers, yeah, the positive, 0, and then the negative in the number line, okay? Now look at this. Normally we'll put 0 like in the middle, yeah? So this is your 0 here. Okay? Now, the right side of this 0 is the positive, yes. So this is number 1, 2, yeah, 3, and look at this, they are equally spaced, yeah. So this is just approximation where they are located. Now, when we have these positive numbers, you also have negative number, and where do you think they are located?
The negative numbers are located on the left side.
Left side. Now, this is the negative. Now, look at this. What we had before, you have 12 minus 4, right? And I told you that this is like you have 12 and then plus negative 4. Yeah. Now let's draw these 2 values in your number line. So what happens is when you have when you have a positive number like 12, now you start from this 0 and then you go to right side, like 12. Yeah, see, from 0 and then you end here, so this is your 12. Okay, now when you have -4, what does it mean?
You go back until you reach
4. Yeah, so basically you can do like this from 0 until you go to -4. Yeah, so this is -4. Okay, so basically if you have a positive number, you have an arrow going to the right. But if you have a negative number, it's like you have an arrow and it's going to the left. Yeah. Now, let's suppose you move the green arrow. So you move the green arrow. Basically, what I'm gonna do is, if I have, the first one, which is this red one, 12, yeah, to the right, and then after that I have another arrow which is to the left, yeah, because it's minus. So what you will have is now a value. So if you look at this now, yeah, again from 0 until the final point here, which is 8. And if you look at where this arrow pointing, yeah, you see we start from your very original, very initial point, and then it ends at your final point here somewhere. So this is actually the value. So that's actually how can you visualize these real numbers in the number line. When you have 12 minus 4, it's like you have 12 and then plus -4. And now you see where the 12 goes and the -4 goes.
Technically minusing the number that's the negative from the number that's the positive, because from 12 minus 4 equals 8, and 8's the answer, so it's technically minusing the negative number from the positive number.
When you say minusing the negative number, actually that's not the same as this one. Okay, so the idea here is actually simply you have two numbers, yeah, for example 12, and then you subtract with 4. That's it. So this is how you visualize. So I haven't talked about, for example, if you have a positive number and then you subtract by a negative number, because that will be something looks quite different, yeah, and we will talk about that later. Okay. But at this time, what you wanna see, what you wanna know now, is that when you have 12 minus 4, it is not the same as 4 minus 12. Yeah. But now if you want to use the commutative property, you need to know that the minus sign here is like you have 12 plus something which is -4, and therefore now it's -4. Yeah, it's -4 plus 12. Oh, sorry. Yeah, okay. Yeah. So that's the commutative property. Okay. The next property that I wanna discuss with you, it is called the associative. So what the associative means? So this is number 2, yeah. It is called the associative. Associative simply means if you have, for example, 2 plus 3 and then plus 5, yeah. Okay. Now the way you can do like this calculation, you can add these two numbers first, and then you will add with 5. But this is actually the same thing when you have 2 plus 3 plus 5, but then when you do this one, you do the 3 plus 5 first, and then after that 2 plus 3 plus 5, right? So this is actually for an expression that has more than 2 terms. Yeah, for example, you have 3 terms here, yeah, and then basically you will do the first 2 terms, and also you can also do the last 2 terms, and they give you the same thing. But be careful, because if you notice here, yeah, what we do here is only for the same type of calculation. For example, addition and subtraction only. So there is no mixed sign in there. So basically, if there is a multiplication, you can't do this. For example, let me show you. Yeah, if you have yes. So now look at this. When you have, for example, 2 times 3, and then you have plus 5, yeah. So if you see in an expression like this, there are 2 things that you have. For example, you have multiplication and then you have addition, yeah. The thing is, they have different level. So what happens is you have to do the multiplication first. So in this case, you have to do this 2 times 3, which give us 6, and then plus 5. Okay. So it will give you 11. So what I mean by this is, if you look at, for example, when you do 2 times 3, is so basically it's like you put a bracket here, right? Okay. Because you are doing it first. 2 times 3 gives you 6, and after that you plus 5. Now look, that's actually, if you now look at this one, so you have 2 times 3 plus 5. It's not the same with this one. When you put the bracket
8
now,
times 2, 16.
Yeah.
We get different answers.
That's true. So this one is 2 times 8, and then you got 16, which is different. So now from this example, you see what I explained to you before was, it only applies when the sign that you have, they're the same level. For example, addition and subtraction, or even when you have multiplication, yeah, for example, 2 times 3 times 5. Okay. Now, if you have all of them, they are all multiplication, and then you try to do this 2 times 3 first. So what's that?
That's 6
times 5,
which is 30.
30. Now look at this. When you have now the same, which is 2 times 3 times 5, yeah. So
brackets around 3 and 5.
Yeah.
Which
Now
15 times it by 2, which is 30.
Yes. So this property, the associative, yeah, basically only applies when you have the same calculation, same type of calculation, for example, addition or subtraction, or you have the multiplication or division. So in other words, I can write down that the associative property, yeah, basically when you have A plus B plus C and then you do the calculation for A and B first, is the same, so it equals when now you do B plus C. Okay?
Okay.
Or if you have now all of them, they are all multiplication, A times B times C, and then you want to do A times B first, yeah? That actually gives you the same thing as when you do
A times B times C brackets around B and C.
first. Okay? So the first property, it was called commutative. Remember what that one was?
Yes. Switching, for example, if you have 4 plus 12, you switch it around to 12 plus 4.
Yeah, or if you have 12 times 4.
You can switch it around to 4 times 4.
Yes, so when you have A plus B, it is equal to B plus A, yeah? Or when you have A times B, it is B times A. Okay? Now, the second one is called the associative. Associative means you have more than, you know, 2 terms, yeah? But the calculation involved here, they are the same level. So basically you have all of them addition, okay? Or all of them multiplication.
Okay.
So what happens here is just you move the bracket.
What if it's plus and minus and multiplication and division?
So, okay, you can have subtraction with the addition altogether. Yeah, for example, you have something like this. You know, 10 minus 5 and then plus 6. Now, when you do this one first, what's this?
10 minus 5 is 5, plus 6, 11.
So this is 5 plus 6 and gives us 11, yeah? Now, if I have, for example, 10 minus 5 plus 6, but then what you want to do is you want to do between this and this. Okay, so remember when I told you about the negative when we did 12 minus 4 before? So it's like you have 10 plus minus 5.
10 plus minus 5.
Yes. Now look at this. 10 plus minus 5 and then minus 6. So what you do with this?
Plus 6.
Yeah, you will do minus 5 plus 6 first.
Negative plus that makes 1.
Yes. Remember the number line that you saw before? If you have 6 to the right, okay, and then negative 5, which is an arrow to the left. So now what remains here is this small arrow to the right. So you go 6 to the right, you go 5 to the left. What's left?
1.
1. So that's correct. This minus 5 plus 6 give us 1. Very good. And then you add to 10, 11. So, well, with the associative, of course, with addition, you can also have subtraction in there, and basically it will do the same thing. You can move the bracket around, but you cannot have, for example, the addition and multiplication in one single calculation like this, and then you move the bracket because you have seen the proof of it, and they are different. See this one again? Yeah, you have multiplication here, and then you have addition. Now, if you move around the bracket, that gives you the different number, right? Okay. Now, with, you know, if you have multiplication with the division, what happens is you can have this associative property, so you can still move the bracket. Okay. Yeah. For example, let me give you an example of it. Yeah. So, say for example, I have 10 divided by 2, yeah,
Okay.
and then multiplied by 3.
That's 15.
That's 15. So in this case, you do
1
like
divided
this.
by 2, which is 5, times by 3, 50.
No, right. So now the idea here is, oh, okay. So actually, what happened was, in this case, we have to be careful now. Yeah. So when you have something divided by 2, yeah. Look, if you move the bracket,
Oh, that'll be impossible.
it's not impossible. But when you move the bracket now, look at this. See, when you move the bracket, what happens is you multiply 2 and 3,
which is
6.
6. And then divide by 10.
Now 10 divided by 6 gives you different value, right? Okay. So what do you think?
I think the answer, like for this one, is 2 point.
No, it's around 1 point something. But what I'm trying to show you here is actually, now you see, when you have multiplication and division, yeah, that's actually similar like before. You can't just move around the bracket. Okay. So what do you think when you have division? Actually, the division and multiplication, they are the same level, yeah. So but then when you look at the bracket here and you just move it like this one, that doesn't give us the same answer, right? Now, the thing is like this: when you have division, yeah, so actually it's like we have a fraction. Remember when you have, for example, 1 divided by 2?
I can make it the same answer.
Yeah.
I can make it the same answer.
So how is
Put
that?
the bracket here, and then,
No.
and if there's a way to close this off,
no.
And then
So what I'm trying to show you here is, when you have, for example, a division, yeah, see 4 divided by 2, yeah. Now we can write down the division like this into a fraction. You know, so if I have 4 divided by 2, how can you write this into fraction?
Of course, like the answer.
No, not the answer. I know the answer is 2. But if you want to write down this into a fraction, so in the school, have you learned about this? Okay. Look, when you have a division, yeah, let me tell you, actually, you can write down this into a fraction, which you will have something like this, 4 on 2.
Which is an improper fraction.
So 4 on 2 is actually the same thing as you know, 4 divided by 2. Yeah, it gives us 2. Right? Now what about 12 divided by 4?
Is into 12 on 4.
Yeah. Which is 3.
Yeah.
Yeah. So now look at this idea. If you have 10 divided by 2 times 3, yeah, this operation is also the same as 10 on 2, yeah, you multiply by 3.
Which is
So
13 on 6.
no, what you did before, yeah, you divide directly 10 divided by 2, which give us 5, right? Yeah.
Yeah, and then times.
But now if you look at this one now, where you have 10 on 2 times 3. So this is actually the same as 10 multiplied by, sorry. So now what about if I have just an integer like this one? So if I have 3, yeah, this is like, you know, 3 divided by 1 or 3 on 1. Okay. So when you have 10 on 2 times 3, what happens is now you are multiplying 10 on 2 times 3 on 1. See, because what happens here is you have fraction, and then when you want to multiply with something, it's better to convert into fraction as well. So now when you have something like this, 10 on 2 times 3 on 1, 30 on 2, which is 15.
Okay.
Yeah. So I think we need to be careful now, because this is a good example when you look at the example from you know, the multiplication and division. Yeah, 10 divided by 2 times 3, and then you try to do this. Yeah, it is not the same with 10 divided by 2 times 3. So usually if, you know, the operation is just addition or multiplication, yeah, therefore you can always do a plus b plus c equal to a plus b plus c, and then you move the bracket. Or if you have a times b times c, now it gives you also a times b times c. This is also the same as like this. Yeah. Okay. So this is the first two properties. Yeah, the first one is called commutative, and the second one is called associative. You know, actually there is one more, but that one we will talk about this next week. Yeah, the third property. So I guess now it's good to have some practice with this kind of calculation. Yeah, so you know which one comes first. So this is like very basic stuff in algebra when you are dealing with you know, addition, multiplication, or subtraction. Yeah, so you need to know which one comes first, which one you have to do first. Okay.